Hi, today we'll discuss this problem, the strongest build. It is actually from the recent educational Codeforces round 114 that happened on Codeforces. So let's look at the problem statement. So the problem statement states that Ivan is playing yet another roguelike computer game. Okay, he controls a single hero in the game. The hero has n equipment slots. Okay. There is a list of CI items for the ith slot. The jth of them increases the hero strength by aij. Okay. The items for each slot are pairwise distinct and are listed in the increasing order of their strength increase. So AI1 will be less than AI2 and so on. So let me explain what this paragraph is saying. So basically in a game we have n slots, right? We have n slots. Let's say if n is 5, then we have 5 slots. For first slot we have some CI choices, right? Let's say these are CI choices. For second, I think I can say for first slot we have C1 choices, right? Some choices may be 1, 2, 3 and the count would be C1. For second slot we have C2, some choices C2 which are whose count is C2. Then for third slot we have C3 and then so on, right? And in input actually the choices are given in increasing order and they are pairwise distinct. What does it mean is, let's say we have 3 slots, n is 3, and for first slot we have let's say 3 choices. So I'll say okay, the choices are 1, 5 and 7. So they will be listed in increasing order, right? And they are pairwise distinct. So pairwise distinct means they all would be distinct, like 1, 5, 7, right? Every one is distinct. Similarly for second slot, let's say we have 2 choices and it's 2 and 5. For third slot, let's say we have only 1 choice, which is 3, let's say. So this is how the first paragraph explains the problem. Now let's look at the second paragraph. So for each slot, Ivan chooses exactly 1 item. Okay. Let the chosen item for the ith slot be the bith item in the corresponding list. The sequence of choices, which is B1, B2, Bn, is called a build. Okay, so it defines actually second paragraph introduces what is a build. So let me also tell you what is a build. Right, so as I discussed, we have n slots. Let's say in example we have n is 3. For this first slot we have like some list of possible choices of numbers. So let's say we have something like 5, 8, 9, let's say. For second slot we have some choices, let's say 2 and 4. For third slot we have some choices, let's say 3 and 6. Now this 5, 8, 9, what will be their indexes? So its index would be 1, then 2, then 3, right? Because for first slot we have 3 choices, and right, for first slot we have 3 choices and their index would be 1, 2, 3, right? Then for second slot we have 2 choices, their index would be 1, 2, right? We are talking about 1 based indexing here, right? For example sake, so the index will start from 1. Similarly for third slot, the index will start from 1 and we have 1, 2. Now what we can do is what Ivan will do. Actually Ivan is the hero or something, the story. He will choose exactly 1 element for each slot. So basically for first slot he'll choose exactly 1 element out of these 3. So let's say he chose first from this, so I'll say okay, let's write 1 here. Then for second slot he'll choose exactly 1 element. Let's say he chose second item, so I'll say okay, second item. Note that these are not values, they are indexes, right? This 1 is not value, this is index of the value that I have taken, right? And then let's say for this third slot, Ivan has chosen this first index, so I'll say okay, then let's write 1. Now this 1 to 1 is actually a build, right? This is actually I can say this is a sequence of indexes, right? Sequence of some indexes. So this is what a build is, right? Okay. Now the strength of a build is the sum of strength increases of the items in it. Okay. So it says that the strength, right? Let's discuss what is the strength of a build. Yeah. So strength of a build, right? So we discussed what is a build. It will be a sequence or maybe n numbers, right? We have n slots. For every number, we will be having an index. This index actually tell me that which out of all the possible choices for this particular slot, which number Ivan chose, right? Actually chose. If it is 1, then I'll say okay, the first index number Ivan chose for the first slot, right? For the slot, Ivan chose the first index guy. So what is the strength of a build? The strength of the build is actually the value for all these indexes, the sum of values for all these indexes. So since the build is 1 to 1, I'll say okay, these are indexes, right? Not values. So I'll say okay, what is the value at first slot, first index? For first slot, what is the value of first index? I'll say okay, it is 5. Then I'll say okay, what is the value of second slot, second index? So I'll say okay, this is 4. And what is the value for third slot, first index? I'll say okay, this is 3. So the strength for this build is actually 5 plus 4, which is 9, plus 3, 12. Right. So this is how we'll say we'll introduce the strength of the build. Okay, that's clear, I think. Now some builds are banned from the game. So there is a list of m pairwise distinct banned builds also. Okay, so basically now as we have discussed the builds, now there are actually some banned builds also, right? Some banned builds also, and they are also we have also actually given these builds in the input. Okay, and it's guaranteed that there is at least one build that's not banned. Okay, now what is the build with the maximum strength that is not banned from the game? Okay, if there are multiple builds with the maximum strength, print any of them. So let me just explain the problem to you. So first of all we have n slots, right? For every slot we have some choices. Then okay, so let's say we have 3 slots, right? 3 slots. For first slots we have 2 choices, which is 5 and 7. For second slots we have 3 choices, let's say 2, 3, 6. For third slot we have 2 choices, let's say 1, 2, right? So now tell me one thing, that how many builds are actually possible using this information, right? How many builds are possible, right? How many builds we can create? How many builds we can create, right? So I'll say okay, exactly I have to choose one guy for this index, one guy out of these for this index, and one guy out of these for this index. So I'll say okay, I have 2 choices for first slot, I have 3 choices for second slot, and I have 2 choices for third slot, right? Basic combinations, right? So it would be 2 into 2, which is 4 times 3, 12. So 12 builds are possible, right? So total we can actually have 12 builds possible, right? 12 different builds possible. Now in this problem we are also given some m builds, right, that are actually banned from this game. So we are given some m builds, and they will be distinct builds, and they are actually banned from the game, so we cannot use this build. Now the question tell me that okay, what is the build that is actually having the maximum strength, right? Maximum strength, and that should be not banned from this game. So I should output this build which is having the maximum strength and it is not banned. In other words, I can say out of all the non-banned builds, out of all the builds that is not banned, I should take the build with maximum strength, right? Yeah, I can say this. Okay. So I think we have read the problem entirely. Actually, the problem is the problem statement is quite large. That's why I took so much time to read this. So let's look at the input. So we have a single integer n, the number of slots. Okay, n is actually up to 10. Okay, then we have the ith of next 10 lines contains the description of the items for ith slot. Okay, basically the choices, right, for ith slot. First integer is ci. Ci is 1 to 285, the number of items for the ith slot. Okay, if first slot is having 5 choices, then first will be given 5, right? Because then I can take 5 different numbers as input. Then we'll be having ci integers, right? Correct. Sum of ci doesn't exceed 2e5. Okay. The next line contains a single integer m. Okay, the number of band builds, right, that I just discussed. Then we'll have the description for these band builds. Okay, the builds are pairwise distinct. There is one more actually important note in the problem. It is this: it's guaranteed that there is at least one build that's not banned. What does it mean? Let's say in some case, if we have 12 possible builds, right, or maybe I can say 12 total builds possible, and we are also given 12 builds that are banned, right? In other words, there is no possible answer, right? There is no build which is not banned here in this case. So the problem actually explicitly states that it's guaranteed that there is at least one build that's not banned. So it won't happen, right, in the inputs. Okay, so basically we can say that there must be the answer possible, right? The answer should be possible. So okay, right, so basically we should find out what is the build with the maximum strength that is not banned. Okay, so ideally how should we approach this problem, right? So one thing, like how should we approach this problem, right? Let's discuss how to I'll say how to approach. One possible way is, okay, let's say I just want to know the build with the maximum sum that is not banned, right? Okay, so I'll say, okay, let's find out all the builds that are possible. Okay, so let's say if I somehow have all the builds that are possible, then one by one I'll check if this build is banned, then ignore it. If this build is not banned, then it could be my valid answer, right? If this build is not banned, it could be my valid answer, and out of all those valid answers, let's take the build with the maximum sum. So this should be the actually basic approach, but let's see if it is actually possible or feasible or not to implement. So since we have n slots, right, n slots, and we'll be having some choices for these slots, right? Let's say for this slot I have 100 choices, for this slot also I have 100 choices, for this slot also I have 100 choices, for this slot also I have 100 choices, maybe let's say 1000. If I tell you how many possible builds can be here in this case, so you'll say, okay, just multiply all of them, right? And it will be very large number actually. It will be 1e3 times 1e3 times 1e3 times 1e3, which is 3 plus 3 6 plus 3 9 plus 3 12, right? So I'll say okay, processing all these builds 10 to the power 12 builds is not possible, right? So this idea is correct but not feasible actually, because there can be many builds, right? There can be many builds, so I cannot just find out all the builds and then process one by one. There should be some smart way. So let's see. Let's say I have somehow find out all the total builds, right, possible, and I have sorted them. I have sorted the builds based on their sum in decreasing order. What I'm trying to say is, let's take an input. Let's take the sample input. So it's actually we have 3 slots. So okay, and for first slots we have 3 options, right, which is 1, 2, 3. For second slot we have 2 options, which is 1 and 5, and for third slot we have 3 options again, 2, 4, 6. Okay, yeah. Now how many total builds are possible? So I'll say okay, 3 into 2 into 3, which is 18 builds are possible actually, right? Now I'll say okay, if they are actually sorted in increasing order, right, what will be the strongest build possible? What is, or what will be the strongest build possible from this example? So I'll say okay, since they are actually sorted in increasing order, so for every slot the highest value possible is placed at last index, right? So I'll say okay, I'll take this guy from here, I'll take this guy, and I'll take this guy, right? And this build would be third index from here, second index from here, and third index from here, right? I'll say okay, this will be the strongest build possible, right? Now tell me one thing, if this is the strongest build possible, I should just check whether this build is banned or not, right? Let's say if this build is banned, then what, let's say if this build is not banned, okay, if this build is not banned, it is the strongest build possible. So I'll say okay, that's it, I found the answer, because that's what I need to find now. I should find the strongest build possible which is not banned. So I'll say okay, I took out this strongest build which is actually possible out of all the total builds, and I just checked whether this is banned or not, and I have found out that okay, this is not banned. So I'll say okay, this is my answer. That's it, we have solved the problem. But now let's look at the other case. When this build is actually banned, then what should I do? Then I should actually find some build which is just next smaller than this strongest build, right? And then I should check whether that build is banned or not, and I should repeat this process, right? Okay, now let's say if we have some builds here, this is build 1, this is build 2, right? Now let's assume what I'm telling you is, let's assume that I have somehow calculated all the builds possible, right? And I have sorted them based on their sum in decreasing order. It means the strongest build will come here, right, which is build 1, let's say. This is strongest, right, because I have sorted them in decreasing order based on their sum. Then we'll have build 2, right? This is next strongest, like it will be smaller than strongest for sure. Then we'll have some next build, and so on, right? They are actually sorted in decreasing order. So if we are going from if we are going here, then their strength is decreasing, right? Actually their strength is decreasing, right? So what I'm telling you is, let's say if I check for this build, the strongest build, if this is banned, if this is not banned, then it's my answer, right? But if this is not banned, then this is my answer. But let's say if this is banned, right, this actually red color indicates banned, then I'll check for this guy, second build 2. I'll again do the same process, whether this build is banned or not. If this build is again banned, if this build is not banned, right, then I'll say okay, this is the answer, because this is the maximum possible build, maximum strength, right? The possible build with maximum strength which is not banned yet, which is not banned actually. I'll say okay, this is my answer. But what if this is also banned? Then I should tell that this guy is answer, right? What if this is also banned? So I'll say, okay, like some guy here that is not banned will be my answer. Let's say this is build K. Now if build K is the answer, right, there is actually one very good observation. Let's say if build K is my answer, then all of the above builds, right, all the builds that are above build K must be banned, right? Because we actually want the maximum possible strength build which is not banned yet. So if this is not banned, I'll say all of the builds above it should be banned, right? Otherwise, if some of it is not banned, let's say if some build is here which is not banned, then I'll say, okay, this is the answer, right? Why this will be the answer? This must be the answer, right? Then so there is one observation that if we have actually sorted all the builds in decreasing order based on their sum, then I'll say, okay, these are the builds, right? And I'll say if this guy is the answer, let's say this guy is the answer, then I'll say, okay, all of the builds above it must be banned, right? All of the builds above it must be banned. So this is one important observation, right? Now, okay, right, so this is clear, right, that if we have the answer, then above it all of the bends, what do I mean by above? All of the bends, all of the builds stronger than this guy should be banned, right? Okay, so now my first approach, my first step, right, my first step should be to check for the strongest build possible. And we know that what is the strongest build possible, because if we have some slots, then I'll say, and they have some choices, then I'll say, okay, the strongest build possible will be, just take the last element of, for all slots, just take the last element, and this will be the strongest build possible, because they are actually sorted in increasing order. So for every slot, the maximum element is placed at the last, so I'll take the last element, right? Right. So I'll check for this guy whether this is banned or not. If this is banned, if this is not banned, we have the answer for sure. Otherwise, I have an observation that for my answer, right, for my build K, which is actually my answer, all the builds above it, right, must be banned. They should be banned from the game, right? So now let's say my build, the answer build, which is actually, let's say the answer is somewhat this A1, A2, A3, or maybe let's say the answer build is I1, I2, I3, I4. Let's say we have 4 slots and the answer build is something like this: I1, I2, I3, I4. And this I1, I2, I3, I4 are actually indexes, right? Now, okay. Now let's say if I can, or maybe let's take an real example. So let's say we have 4 slots or maybe 3 slots. For first slot, there are actually 4 possible choices. For second slot, we have 5 possible choices. Let's say these are choices, right? These are CI. For second slot, we have 2 choices possible. And let's say my answer build is looking something like this. Let's say I took third guy from here, maybe fifth guy from here, or first guy from here, right? Okay, so this is my answer build. Let's say in some scenario this is the answer. Now the observation is here is, since I can actually make this 3 to 4, right, because this is allowed. Since we have 4 choices, I can take 1, 2, 3, 4, but I have taken 3 in my answer. It means I can actually upgrade this guy to 4, right? So the build 451 will be actually stronger than this answer. But as I have discussed that all the stronger build than answer, all the builds that are stronger than answer must be banned. So I'll say okay, if I am able to upgrade it, then this guy 451 should be banned, right? Right. So the observation here is, let's say this is my build, answer build, and we have I1, I2, I3, right, for 3 slots. Let's say if I can upgrade any one of it, right? Let's say this, we have C1, C2, C3. For some I, let's say this I, let's talk about I2. If this is less than C2, it means we can upgrade it, right? We can make this I2 to I2 plus 1, and it will be stronger guy. It will be stronger build. But that build should be banned, right? So if this is my answer, then that build should be banned, right? So okay, so this is first observation, that for answer, let's say if we have the answer build, and at any index, if the index is actually upgradable, then that resulting build must be banned, right? Okay, now can I say the reverse thing? If I know that for answer, if we try to upgrade it, we'll reach the banned build, right? Can I say the reverse thing? Can I say that okay, if for some banned build, if I downgrade it, we'll reach answer? Can we say that? For some out of all the possible banned builds, if we downgrade the banned build, by downgrading what I mean, let's say the build is something like 1, 4, 5, then I either decrease this guy or this guy or this guy if it is possible. Since we cannot decrease 1, right, because 1 is the leftmost guy for first slot, so we can decrease this guy or this guy, right, from the banned build. So what I'm telling you, that if we know that by promoting the answer build we can reach a banned build, so we can also say that for some banned build, right, for some banned build, if we downgrade it, we will be reaching our answer, right? So now what we can do, since actually banned build are limited in numbers, right, we have actually 10 to the power 5 banned builds. What I can do is, so I know this, right, so what I'll try to do is, for every banned build, I'll check for first build, I'll check whether I can downgrade this or not. If I am able to downgrade this, then I'll check okay, I am able to downgrade this. Let's check. Okay, let me tell you here. Yeah, let's say if this is the banned build in this example, or maybe in general, let's say if we have a banned build, right, it is 2, 4, 5, then I'll see okay whether I can downgrade this or not. So I'll check for first slot. I'll see okay, this is 2, so I can make it 1, right? So I'll say okay, one downgraded build would be 1, 4, 5, right? This is actually downgraded build. Now I'll check when this build will be a possible candidate for my answer. So it should be not banned, right? It should be not banned. So I'll check whether this build is banned or not. So out of all the possible banned builds that we have, right, we have in the input, right, here we have that the number of banned builds is 10 to the power 5, and then we'll have a description of banned builds. So we'll check whether this 145 is actually inside this or not. If it is not, then this is the candidate for my possible answer, right? This is a possible candidate, and out of all these possible candidates, I'll just take the maximum the build with the maximum sum, and I'll just print this, right? So first of all, what I'm trying to do is trying to process all the possible options, or maybe I can say possible candidates for answer, right? For answer build. Out of all those, let's say we have these builds. Out of all these builds, I'll say, okay, let's take the build with the maximum sum, and this would be the answer, right? So that's what we are going to do. So for every band build, first of all, we will check whether the strongest build is banned or not, because we know that the structure will look something like this. If we have sorted all the total builds based on their sum in decreasing order, then let's say if my answer is somewhat here, this is answer build, then we have this observation that above build should be banned, right? These builds must be banned. So we know this, and then we have an observation that from this answer, if we promote this, we'll reach band build, and then reverse is also true, right? For some band build, if we downgrade it, we'll reach our answer, right? If it is not banned, then we'll reach our answer. For some, that's why we'll be taking the max out of all those possible candidates for the answer, because it might be possible now for this build we are reaching somewhat here. Yeah, we have some more guys here, so it might be possible that for this build we are reaching here. For this build, if we demote it, we are reaching here. But for this build, if we demote it, we are reaching here, right? It is also possible that demoting a build, we are reaching a band build, because let's say for this guy, if we demote this, we are reaching here. It is also possible. So we will take all these possible downgrade options, and we'll check for two things. We'll check for actually one thing, whether this option is banned or not. If it is not banned, then I'll say, okay, this is a possible candidate for the answer, and I'll just take, out of all the possible candidates, I'll just take the maximum strength candidate, right? So first step is, now actually we are moving towards the solution. So first step is to check whether the strongest build is answer or not. So to check whether the strongest build, right, strongest possible build, which is for every slot, take the last element. So I'll just check whether this guy is banned or not. So one more thing, how will we check if a build is banned or not? How we will be checking this? If we have a build which is a vector, so one thing I can do is, out of all those builds, right, just check one by one whether this build is present here or not. Or maybe there is a smart way we can use a map, right? We can use a map of vector int to int, right? And in input we actually got m bandwidths, right? What we can do is we can store all of the band builds in a map, and we'll say, okay, yeah, we will store these builds in the map, and then to check whether a vector is actually a band build or not, I'll just check whether this vector is present in this map or not, right? So checking in map is actually faster. So yeah, this is a faster way to check whether a build is banned or not, instead of traversing the whole possible banned builds. We can store all the banned builds in a map, and just for checking whether a vector is, or whether a given build is banned or not, we'll just check in the map itself whether this guy is present or not. So first step for the solution would be to check for the strongest guy, right? The strongest guy, which is for every slot, take the last number and just check whether this guy is banned or not. If this is not banned, we got our answer, right? Because this is the strongest guy possible. So we got our answer. But let's say if it is banned. If it is banned, then we know that our answer is here. And above it, all of the guys will be banned, right? These are banned builds. So now what I'll do, for every build, I'll check for options. I'll check for downgrade options, and for all those not banned downgrade options, I'll say okay, the one with the maximum strength will be my answer. So I think, yeah, that's it. Let me just first discuss one more thing, which is how we'll be downgrading a banned build. Let's say we have a banned build, something like 254. Then I can say, okay, it can be downgraded to 154, right? Just downgrading this slot. Maybe it can be downgraded to, let's downgrade this slot, so it will be 244. Or maybe it can be downgraded to, let's downgrade this slot now, so 253. Now my next step would be, for all these downgraded options, I'll check whether this build is banned or not. If this is not banned, let's say, then I'll say okay, let's calculate its sum. If its sum is greater than the sum that I have found till now, then I'll update my answer, right? The one it is similar thing that we do with taking the max of some things, right? So out of all those things, I'll just take the maximum strength guy. So I think, yeah, that's the solution approach. First step is checking the strongest build, whether this is answer or not. Otherwise, if this is banned, strongest build is banned, then the second step is, for every banned build, check for the downgrade options, because we have discussed that there will be some build for which if we downgrade, we'll reach our answer, right? So we'll try for every possible downgrade, and then if the downgrade option is not banned, I'll say okay, let's, out of all these possible candidates for the answer, let's take the maximum one. Right, now let's discuss the time complexity for this approach. So for checking we have m banned builds, right? For every build, I'll check for the downgrade options. So there can be n downgrade options, because for every slot you will downgrade, right? So for every build we have m builds. For every build we have m builds. Now I'll say okay, for every slot we have n slots. I'll check whether we can downgrade or not. If we can downgrade, so we have got a build. Then I'll check this build also, whether this build is present in our map or not. So checking in map is also will take n into log m time, right? Because n is the size of this build, and log m will be the operation, right, to search and is the time required. Maybe you can say map takes log m time to search, right? So the time complexity would be m into n into n into log m, and this m is actually 1e5, this is 1010. So I'll say okay, 1e7 times log of 1e5, and this is actually nice, it will work, right? So actually this n log m operations can be improved using hashing, right? But I think that would be a bit complex. So in this video we'll be using map itself, because I believe this should work in Codeforces. in 1 second time 1 or 2 second. What is the time constraint? 3 seconds, right? So in 3 seconds this should work. So yeah, I think that's the solution, and let's start to implement this, right? Yeah, so we have actually 2 steps, right? These are the 2 steps. First is this and second is this. First is this and second. Yeah, I think we should implement this solution actually. So let's do it quickly. So first of all, we are given n, right? The number of equipment slots. So I'll say, okay, let's take this as input. We have ith of next n lines contain the description of the items. So basically to get or to store these descriptions, let's create a vector of int, right? And I'll say, okay, the name can be value or maybe slot choices, right? Slot choices. And the size would be n because we have n slots. So slots of ij will represent slot I, the choice of slot I at jth index, right? I can say this. Okay, then actually we'll be having for every slot the description for these choices. So I'll say okay. Now first of all, there is a count for these choices. Then let's take the input for every choice. I'll say okay, int choice value. Let's take the input, and then I'll say okay, that's I should push back it, right? In this vector slot choice of I dot push back choice value, right? Yeah, so we have covered this up to this. Then we have m, the number of band builds, right? So I'll say okay, we have m, the number of band builds, and for then we have the description of band builds, right? So let's take the input. How we will store these band builds? We can again create a vector of int, right? I can say band builds of size m, right? So first of all, for we'll be having m vectors. So let's take input. Yeah, so we'll be having, or maybe we can say that its size is fixed actually, because the build size is actually fixed. The size would be n, so I can say okay. Yeah, the syntax is something like this, I think. Yeah, and then I can just simply input this, so it will be band builds of I comma j, right? Okay. Yeah, now let's see our steps. First step is checking the strongest build, right? If the strongest build is banned or not. So to check whether a build is banned or not, we should create a map. So we should create a map of vector int to int, right? We can say check if ban, right? So yeah, and if let's say if check if ban for some vector v is 1, I'll say this implies actually that v is banned, and if it is 0, then it means it is not banned. So what I should do is for every banned build I should map it to 1, right? Because they are banned. So for every build in banned builds, I'll say check if ban of this build is true, because they are banned builds, right? Now what is the first step? First step is actually checking the strongest build, right? Whether the strongest build is banned or not. If this is not banned, then I have my answer, right? Because this is the strongest possible not banned build. So I'll say okay, vector int strongest strongest build, right? So strongest build would be basically having the last indexes, right? And in this indexes we are actually talking about one based indexing, because the input is actually one based, as you can see, 3 2 2, like the input is actually one based indexing. We can confirm it from here. Yeah, from here, since it starts from 1, so this is 1 based indexing. So I'll say okay, the strongest build will be taking the last guy, right, for every one. So let's create a new page. Yeah, so I'll say okay, if this guy has 3 choices, this guy has 2, and this guy has 4, then the strongest build will be actually 3 2 4, right, which is actually equal to the size of them. Because if we have 3 choices, then they will be having something like this, 1 2 3, their indexes, and we'll be taking the last guy, just 3. So I'll say okay, the to build this strongest build, its size would be n. I'll say okay, the strongest build value, or yeah, the strongest build will be actually the size, right? The size of the possible choices for this ith slot. So I'll say okay, I'll say what is size of slot choices of ith slot, right? I'll say okay, what is slot choices of I dot size. This is the strongest build. I check whether to check if ban of strongest build, right? I'll just check whether if this is 0, so it is not banned, so we have our answer, right? So I'll say okay, just print this. I'll say just print this strongest build and yeah, we have got an answer. We don't have test cases. Actually, this is my main function. Here I am taking the test cases, but in this problem we don't have test cases, and for every test case I am calling this solve function, and this is the solve function that I started implementing from. So yeah, that's it. So okay, so first step is actually completed, that we have checked about the strongest build. Now if strongest build is banned, then the second step, right, what is the second step? Second step is for every banned build, check for the demoted options. So I'll say okay, for every build in banned builds, right, I'll check for demote option. So there are n slots, right? For every slot we should check whether we can demote it or not. So for every slot, check whether we can demote it or not, like, right? Now how should we check whether we can demote it to some build or not? So I'll say okay, if the value is greater than 1, then we can demote it actually. But if the value is 1, then it is the leftmost choice, we cannot go further left. So I'll say okay, if build of I is greater than 1, then we can demote for this slot, right? We can demote for this slot. Now let's create the demoted build, right? So the demoted build would be actually just decrementing this I by 1, right? Now I'll check whether this demoted build is banned or not. So if this demoted build is not banned, then I'll say okay, this is a valid possible answer. But I should also store the maximum sum that we have got till now, right? If yeah, so let's create a variable max sum which is 0, and let's create a vector which is answer build, right, which is the build we are looking for. So I'll say, okay, if the sum of this build, this demoted build, is greater than the max sum that we have got till now, so I say, okay, let's update my max sum to this sum, and let's update my build also. So we need the sum of this build, right? So first of all, let's calculate the sum of this build. Let's say sum of this build is actually this, right? Now since we are going to demote this, so I'll say, okay, int sum of demote build, right? It should be we should initialize with sum build, right? Then we should update it. So what we have done here is yeah, so first we have ith element, right, at some slot. We are changing it from I to I minus 1th element. So the sum will change from value at this ith element minus value at this I minus 1th element, right? Or maybe you can say that if the original sum is sum, then we have removed this ith element and added this I minus 1th element. So I can say, okay, the updated sum would be sum minus value at ith element plus value at I minus 1th element, right? Because we have removed this guy and added this guy, since we are demoting for a slot. So okay, so I'll say, okay, the sum, right, so I'll say the sum of this demote build will be sum of build, right, plus value at ith guy. So how to calculate the value? So we have actually stored this here, which is slot choices, right? For every slot we have stored the choices. So I'll say, okay, so I'll say we are talking about ith slot, right, and we are talking about build I value, the value at build I index, build of I index. So I'll say, okay, we have slots choices for this ith slot, and the value would be build of I minus 1. Why minus 1? Because in input we are given 1 based indexing, but here in code we are implementing 0 based indexing. And then I'll say, okay, so it should be minus, right, because this is the original value and we are decrementing it. And I'll say, okay, plus slots choices of build of I minus 2, right? Yeah, this is the previous index for this slot. We have just added this and we have removed the current index, right, because we are demoting it. Yeah, and then we have also changed the build, right, so that if the original build, if the original band build is 235, then we have changed it to, for this slot, let's say we are talking about, so we have changed it to 135, right? That's what this build of I minus minus is doing. Now we'll check whether this whether this build is banned or not, whether this demoted build is banned or not. If this is not banned, then I'll check, okay, if the sum of this demoted build is greater than the sum I have found till now. So I'll say, okay, this is actually, I should update this, right? So I'll say, okay, let's update this, and also for our answer build, I'll say, okay, also update my answer build to this particular build, right? Correct. So now we have covered this. For first slot we have covered this. Now for second slot will be start from the same build, right? Because we are demoting one by one. So I should say, okay, let's restore the state for this build. So I'll say okay, build of I plus plus, because we have decremented it. So this actually became demoted one. Now from demoted we should again upgrade it to original state, right? Because then we'll process the next slot. So I'll say okay, just update it to this, and then I think we'll have an answer build updated for every possible choice. And then after that I'll say okay, just print this answer build, right? So I think I believe that the code is completed. uh, let's run it on sample test cases first check whether we have any compilation error or not. Okay, so as expected we have some compilation error. So the name is slot choice. Okay, so we have declared it as slot choices actually, and we are using slot choice here, so we should be using s slot choices. What's not declared? Oh shit, here it should be slot. And we have also did the same mistake in line number 164, where we are calculating the sum of demoted build. So here also it should be slot. It should be slot. Okay, now we've got some different error. Let's debug this also. No match for operator plus. Okay, where we have used this operator? Here. Okay. Okay, I got it. So it should also be I, right? Otherwise this will represent a vector, because this is a vector of int. Yeah, I think we don't have a compilation error. That's a good news. Let's run this input. Okay, we are getting this 223, which is as expected. Let's run this also. 322. 322. Okay, since this problem can have valid solutions, sorry, can have multiple solutions. So let's look at 1 2 3. 1 2 3 is actually 1 plus 5 plus 6, which is 12, and my code is printing 322, which is 3 2 2, which is also 12, and both are unbound, so I think both are valid answers. Okay, let's look at this 322. Okay, let's look at last test case 111. Okay, I think we should submit it to check whether this is correct or not. Actually this problem was quite hard to be diff 2D in my opinion. Okay, we got wrong answer on test 9. Okay, let's quickly debug this also. Okay, this is correct. This seems correct. Okay, the sum of build is this. Okay, then we have sum build minus slot choices of I, then build of I minus 1. Yeah, that's correct. And then build of I minus 2 should be plus. Okay, yeah, that's correct. And we have demoted it. Okay, answer build, then we'll say okay, build of I, incrementing build of I to maintain its original structure. Okay, are we taking everything correct in the input? In choice value, then I'll say okay, this seems correct. Then here we have band builds. This also seems correct. Yeah, we have check ban. This also seems correct. Then we have strongest build. This also seems correct. Then we are checking whether strongest build is banned or not. Okay, then we have max sum. Yeah, maximum. So can the values be negative? Or maybe we should not initialize maximum to 0. No, they are positive. Okay. For every build in band bits, we are trying to demote it and trying to find out out of all these choices, the maximum possible strength build. So for every element in build, we should increment the sum build by x to calculate the sum. No, actually this is the mistake, I think, because build is actually a sequence of indexes, not values, right? Yeah, correct. So what I'll say, we cannot calculate the sum like this. Instead, what we should do is for every slot, the sum build should be actually slot choices at this ith slot and the index, right, which is build of I minus 1. Yeah, I think it should be. Let's see. Let's see if it is working for all these test cases. I think, yeah, that's the problem. Yeah, I think I should submit this. Okay, now let's check whether this is correct or not. Okay, it is running on test 15. Yeah, it got accepted. Okay, still like it took 1.2 seconds, and instead of using a map here, I've used a map here, right? Instead of using a map here, we can use hashing, right? Yeah, we can use hashing and maybe optimize this problem, but I think this is also fine in Codeforces for a 3-second time constraint. The solution is also good. Yeah, I think that's it for this video. Yeah, that's it for this video. Bye.